Have you ever stood next to something so impossibly large that it felt like it wasn't built by humans, but by a civilization of giants? If you've ever seen a massive mining truck rolling down a haul road, or spotted one of its components being transported on a 12-axle lowboy trailer, you know exactly what I'm talking about. These machines aren't just vehicles, they are mobile industrial complexes. But have you ever stopped to wonder why on earth they need to be this big? Why can't we just use 50 regular dump trucks instead? And more importantly, how do you even keep a 4,000 horsepower beast running without it shaking itself to pieces? Welcome back to Motor Vibe Talk. Today, we're going deep into the world of ultra-class haul trucks. We're going to tear down the mechanics of the legendary Caterpillar 797F and its competitors, look at the staggering costs of keeping them alive, and explore the high-tech future of autonomous mining. This isn't just a look at big trucks, it's a look at the extreme limits of mechanical engineering. Let's start with the why. Why the Colossus? In the world of mining, the only thing that matters is the cost per ton. Moving earth is a game of margins. If you use 100 small trucks, you need 100 drivers, 100 engines to maintain, 100 sets of tires, and you'll burn a massive amount of fuel just moving the weight of the trucks themselves. By scaling up to a single behemoth like the Cat 797F, you can move nearly 400 tons in a single trip. In a 24-hour cycle, these giants move thousands of tons, making the fuel-to-material ratio incredibly efficient. It is the definition of economy of scale. To put the size into perspective, let's look at the numbers. A Caterpillar 797F stands about 23 feet tall. That's essentially a two-story building on wheels. It's nearly 50 feet long and 31 feet wide. If you parked it in front of a standard suburban house, the roof of the house wouldn't even reach the top of the truck's radiator. You could literally take a stroll underneath the chassis between the wheels without even ducking your head. When it's empty, the truck weighs about 600,000 pounds. When it's fully loaded with iron ore or copper, that weight jumps to over 1.3 million pounds. To put that in perspective, that's equivalent to about 4 blue whales sitting on 6 tires. You might think that maintaining a machine this big would be a nightmare, but it's actually designed with serviceability in mind. Most of the critical checkpoints, the oil filters, the fluid sampling ports, and the grease points are located at ground level. Why? Because you don't want a mechanic climbing a 20-foot ladder every time they need to check the oil. However, if you do need to get to the cab, you have to climb a set of stairs that looks more like a fire escape on a New York apartment building. And once you're up there, the view is incredible, but the danger is real. The biggest threat on a mine site is the blind spot. From the cab, an operator cannot see anything within 20 or 30 feet of the front bumper. A standard pickup truck or a Jeep looks like a toy from up there. If a light vehicle parks too close, the operator won't even feel it as they crush it into a pancake. This is why these trucks are fitted with 360-degree camera systems and radar. But even with that tech, accidents happen. There are heart-stopping videos of operators who didn't realize a vehicle was behind them and backed over it as if it were a soda can. One of these trucks could flatten your car, and the operator might just think they hit a slightly larger than average rock. Now let's talk about the heart of the beast, the engine. The Cat 797F is powered by the C175-20. This is a 20-cylinder, 106-liter V-block. To give you an idea of that scale, most heavy-duty pickup trucks in the US have a 6.7-liter engine. This truck has a displacement that is 15 times larger. It features 4 massive turbochargers that cram air into those 20 cylinders, producing up to 4,000 horsepower and enough torque to pull a cargo ship out of the water. When this engine fires up, the vibration can be felt in the ground from hundreds of yards away. It's not a sound, it's a physical force. But all that power comes with a price, a thirst for fuel that would bankrupt a small country. The fuel tank on one of these machines holds about 1,000 gallons. That's nearly 4,000 liters of diesel. On a standard shift, the truck can burn 60 to 70 gallons of fuel every single hour. To keep them running 24/7, mines use specialized service trucks, which are essentially high-speed, mobile gas stations that pull up to the giant, fill the tank, and replenish the high-pressure grease systems and hydraulic fluids without the truck ever having to leave the pit. Every minute this truck isn't moving, it's losing thousands of dollars in potential revenue, so the goal is to never shut that engine down. And then there are the tires. These are the most expensive consumables in the world. On a Cat 797F, each tire stands over 13 feet tall and weighs more than 10,000 pounds. A single tire costs upwards of $45,000 to $55,000. When you multiply that by the 6 tires on the truck, you're looking at $250,000 just for the rubber. The reason they're so expensive is the manufacturing process. These aren't just molded in a factory, they are largely built by hand. Workers wrap layer after layer of raw, sticky rubber sheets around a massive drum, incorporating miles of steel cable to give the tire its structure. It's a painstaking manual process that takes days for a single tire. Once those tires are on the truck, they face a brutal life. Sharp rocks, extreme heat, and massive weight are constantly trying to tear them apart. If a tire on a mining truck explodes, it's not just a loud pop, it's a bomb. The air pressure is so high that the resulting shockwave can flip a nearby pickup truck or kill a person instantly. But the real danger is the bead ring, the massive steel ring that holds the tire to the rim. If that ring fails under pressure, it becomes a 500-pound projectile that can cut through steel. This is why tire maintenance in mining is a specialized, high-stakes career. To handle the massive weight and the rough terrain, these trucks don't use traditional springs or leaf overs. Instead, they use a hydropneumatic suspension system. It consists of 4 massive cylinders filled with oil and nitrogen gas. Because gas can be compressed and oil cannot, the nitrogen acts as a giant cushion, while the oil provides the damping. This system is so effective that it can absorb the shock of a 50-ton shovel dropping a load of jagged rock into the bed from 10 feet up. Without this suspension, the frame of the truck would snap under the stress of the uneven mine roads within a week. And then, here's where the technology gets really interesting, especially for our audience in the US and Europe who love the electric versus mechanical debate. There are actually 2 ways to make these giants move. Caterpillar traditionally uses a mechanical drive, which means the engine is connected to a massive transmission and a traditional rear differential. However, many other brands like Komatsu, Hitachi, and Liebherr use electric diesel traction. In a diesel-electric truck, the engine isn't connected to the wheels at all. Instead, the engine turns a massive alternator that generates electricity. That electricity is then sent through massive cables to 2 enormous electric motors located inside the rear wheel hubs. This is exactly how a modern freight locomotive works. The advantage? Electric motors provide 100% of their torque instantly. This is vital when the truck is trying to climb out of a deep pit with 400 tons of rock on its back. It also eliminates the need for a traditional gearbox, which reduces mechanical wear and makes the truck much smoother to operate. You can tell a truck is electric drive by looking for the massive grid box on the side, which looks like a giant radiator. This box contains resistor grids. When the truck goes downhill, the electric motors turn into generators, creating a braking force. But that electricity has to go somewhere, so it's sent to those grids where it is turned into heat and blown away by massive fans. This dynamic braking allows the truck to descend steep grades without wearing out its traditional friction brakes. It's the same tech used in a Tesla for regenerative braking, just on a 600-ton scale. So, how do you even get one of these to the site? You can't exactly drive it through downtown Chicago or London. They're shipped in pieces, like a giant Lego set. The chassis comes on one specialized trailer, the engine on another, and the dump body or hopper is often shipped as several flat plates of steel. Once they arrive at the mine, a team of specialized welders and mechanics spends weeks assembling the truck on site. The hopper alone is a masterpiece of welding. It has to be thick enough to handle the impact of boulders, but light enough not to kill the truck's payload capacity. Every pound of steel in the truck is a pound of rock it can't carry, so the engineering is a constant balancing act.
As we move into 2026 and beyond, the world of mining is undergoing a silent revolution. The vibe is shifting toward autonomy. Many of the trucks you see in major mines today, particularly in Australia and the American West, don't even have a driver. They're controlled by a central computer system using high-precision GPS, LiDAR, and radar. These autonomous trucks can run 24 hours a day without a coffee break, and they follow the exact same path every time, which reduces tire wear and fuel consumption. It's a bit eerie to see a 1.3 million pound machine moving perfectly on its own, but it's the peak of industrial efficiency. But the real frontier, and the most controversial one, is the zero-emission mining truck. Companies like Komatsu and Caterpillar are currently testing 100% electric prototypes. These trucks don't have a diesel engine at all. They run on massive battery modules integrated into the frame. The challenge, of course, is the weight of the batteries and the time it takes to charge them. To solve this, some mines are using trolley assist, where the truck hooks up to overhead electric wires, just like a city tram, to get the power needed to climb out of the pit, while charging its batteries on the way down. The irony isn't lost on us. We are using massive, high-tech trucks to mine the copper and lithium needed for the electric vehicle revolution. Whether they are powered by diesel or electricity, these trucks are the backbone of our modern lifestyle. Everything you own, your phone, your car, the steel in your house, started in the bed of one of these giants. So what do you think? Is the future of these giants purely electric and autonomous, or will the raw mechanical roar of the 20-cylinder diesel engine always reign supreme in the pits? There's something about the mechanical power of a Cat 797F that just feels right. But as the world changes, these titans are evolving with it. Thanks for joining us for this deep dive into the world's most massive trucks here at Motor Vibe Talk. If you enjoyed learning about the 4,000 horsepower heart of these machines, make sure you hit that like button and subscribe. We've got plenty more stories to tell about the iron, the oil, and the engineering that moves our world. Stay tuned, keep those engines humming, and we'll see you on the next one.